Thank you. Rashmi, very good morning. You please start your presentation. So this is the third day of our session.
So,
21 presentations are gone. Today, B12, Rashmi Mutalik and Nitya Pramod, they are going to present their work on the design considerations of vehicle. I request Rashmi to please start with the presentation.
yes, sir. Good morning, everyone. My name is Rashmi Mutalik, and my teammate is
Good morning.
Nitya Pramod. And the topic for our presentation today is the design consideration of vehicles. In this presentation, we will be covering the introduction, the aerodynamic considerations, in which I will be explaining about the aerodynamics and energy, and Nitya will be explaining about the body or the chassis aerodynamic shape. So, let me begin with the introduction of this presentation. We know that when we design a vehicle, there are certain parameters that we need to keep in mind in order to have a more efficient and optimal output. The parameters may vary from the life of the vehicle to the cost efficiency, weight consideration, and so on. So let me consider one such important parameter, that is the fuel efficiency. The fuel efficiency is the effort that is required to convert the chemical energy from the fuel into the kinetic energy that is required to move your vehicle. And increasing the fuel efficiency is one of the most significant things in the design of a vehicle. So
Correct.
here we have listed two things that can be used to increase the fuel efficiency. The first one is minimizing the mass. We know that more the mass of the vehicle, more energy is required to move it, and in turn more fuel is used. Therefore, vehicles with higher mass reduce the fuel efficiency. The second parameter is the aerodynamic drag. I will be explaining about this in detail in the further part of the presentation. The third is the rolling resistance. The rolling resistance is the energy that is lost due to the drag and friction of the tire. And hence, in the design of a vehicle, tires having lower value of rolling resistances are preferred. The second point is that we can increase the fuel efficiency by maximizing the motor and the transmission efficiencies. We know that in an electric vehicle, the batteries are very expensive. And higher the mass of the battery, it becomes more expensive to design the electric vehicle. And hence, vehicles with higher efficiencies are preferred. The parameters, the aerodynamic drag and the weight positioning are also quite significant, which contribute to the flexibility of the positioning of the components in the electric vehicle. So let me start by explaining the first concept, that is the aerodynamics and energy. We have concluded that aerodynamics is a significant parameter for increasing the fuel efficiency. So let me explain what is aerodynamics. When an object is moving through a stationary fluid, force acts on that object, and that force can be divided into two components. The vertical component of that force is known as lift, and the horizontal component is known as drag. If that fluid is uh, air, it's known as aerodynamics, and that if that fluid is water, then that phenomenon is known as hydrodynamics. The drag force on that object is quite undesirable in many situations since it reduces the fuel efficiency. Here we have the equation of the drag force, that is FAD is equal to half rho ACD into B square, where rho is the density of air, A is the frontal area, CD is the drag coefficient, and V is the velocity. Now, equation of power, PADW, this power is the power that is required to overcome the air resistance at the tires, and it is given by the force into velocity. In this figure that we have shown here, it resembles the ideal aerodynamic shape that is.
Thank you. Please continue.
As we can see here, the power AdW is equal to the force into velocity. This is the power that is this is the power required to overcome the air resistance at the tires. Now let us look at the figure that is given here. This is the ideal aerodynamic shape, and it resembles a teardrop. The length to diameter ratio of this figure is 2:4, and the drag coefficient is 0.04, which is practically impossible to achieve. Hence, this value is taken as a reference point or aiming point to design a vehicle. The aerodynamic drag coefficient for various shapes of vehicles are mentioned here. There are certain examples that have a low value of aerodynamic drag coefficient and are more efficient and effective. One such is the Honda Insight hybrid electric car, which has the drag coefficient of 0.25. Another example that I can give here is the General Motors EV1 electric car, which has the drag coefficient of 0.19, and the record-breaking Bluebird vehicle has the drag coefficient of 0.16. In the power equation, as we have seen in the previous slide, the power is directly proportional to the drag coefficient CD. Hence, the reduction in drag coefficient also reduces the power that is required to overcome the resistance. So
Correct.
vehicles with lower value of drag coefficient require less power to overcome the air resistance and hence are
Correct.
more efficient. This is here we have written the equation for battery power, that is PADB, which is equal to the total power divided by the total efficiency. Now, if I talk about this graph, the x-axis represents the speed per kilometer hour and the y-axis represents the power that is required to overcome the drag at various values of frontal areas and CD, that is the drag coefficient. Now, if I
Correct.
consider the instance A equal to 2 meters square and CD is equal to 0.23, at these values of A and CD, the power that is required is highest. So we can tell that at high speeds and high frontal areas, the drag coefficient is more and hence more power is required to overcome the resistance. Now, if I take an example of A is equal to 2 meters square, even though the value of the area is same, the value of CD reduces with the reduction, value of C reduces and the power required is lesser. Hence, the value of C is very important to calculate the power that is required to overcome the resistance. The formula for battery mass MB is given as PADB into D divided by V into the specific energy into 3600 kgs. This is the formula for the battery mass MB. Okay, so this is the graph that represents the speed, that is the speed per kilometer hour versus the mass of the battery that is required to overcome the drag. We can see from this figure that the higher the mass, the more power is required to overcome the air resistance for a greater value of CD. And we can also conclude from this graph that electric vehicle batteries are not efficient at high speed. Because for the lead acid battery, even though it has a lower value of CD is equal to 0.19, it still requires around 300 to 400 kgs of mass at a speed of 140 kilometer per hour. From the
Correct.
previous two graphs and equations, we can conclude that the frontal areas and the aerodynamic drag are two important factors in order to increase the fuel efficiency of the vehicle, since the total resistance that the vehicle gives is equal to the frontal area plus the aerodynamic drag. So these two factors are crucial in determining the fuel efficiency, and hence it is very important that in the design of the car that these two factors are kept lowest as possible, and it also helps in saving the cost on battery weight and it helps in saving on both battery weight and battery cost. To reduce the aerodynamic drag, other parts of cars such as wing mirrors and windscreen wipers also have to be designed smartly in order to have the less aerodynamic drag in a vehicle. The further part of the presentation will be continued by Nitya.
Thank you. It's quite a good presentation you have given. So you have really explained from your understanding. Good work.
Thank you, sir.
Yeah. So make it full screen and then start.
Thank you, Rashmi, for presenting the first part of the presentation. Now I'll be presenting the second part. The specific use of electric vehicle largely determines the aerodynamic shape of the vehicle. Now, basically, we're talking about the body or chassis aerodynamic shape. So, basically, chassis is an unfamiliar term. It's nothing but the basic frame of the car, or you can say the skeleton frame of the car. Now, before we go into the topic deeply or understand the significance of aerodynamic shape, we need to understand what aerodynamics is or what aerodynamic drag is. So, aerodynamic drag is basically the force that is acted upon a moving object by the air when it's traveling at a high speed. Now, usually when it's a very windy day or when you're not when it's a windy day and suppose a car is traveling at a high speed on the highway, we cannot, it's not really visible to bare eyes, but the car tends to experience a force that is obstructing it or it's resisting it.
Nitya, are there two sources at your side? Are there two sources? Because the sound is echoing. Is there a mobile or something on at your end?
Yes, sir. One second.
Yeah, so mute that.
So is it okay now?
Yeah, you speak. I think it is okay. That was giving some echo.
So, as I was mentioning, when a car is traveling at a high speed, it's not visible to bare eyes, but the car tends to experience a obstructing force. This force, which is experienced when the car is exposed to air or wind, is known as aerodynamic
Yeah.
drag. Now, why aerodynamic drag is important is because it has a tremendous effect on how the car will accelerate all throughout the journey or how it will attain a particular fuel mileage. Now, what is aerodynamics? Aerodynamics is nothing but the force that I was talking about. It is the study of these forces that result in motion of objects through the air. Now, if you actually observe over the years, car designers and car makers have kept this aerodynamic drag in mind and then created a car design. If you actually observe a car that is designed based on this aerodynamic drag, tends to attain the fuel mileage or tends to attain a fuel economy number faster or in a more smooth manner compared to the one which is not
Correct.
designed keeping the aerodynamic drag in mind. Now, now, coming to the next topic. Now, when you actually talk about aerodynamic shape, I'll be using two examples, that is the Honda Insight and the GM EV1 car as examples to draw parallels between the importance of underbody design and also the teardrop shape. Now, if you this is a figure of the Honda Insight, you can actually see that towards the end of the car, the back end of the car, it is abruptly cut off. This is known as the cam effect. Cam effect basically it basically tells that instead of wasting material in creating a car with having long unnecessary tapered ends, will give you the same benefit when it's cut off. It both give the same advantage. So instead, you can just cut off the tapered end to reduce the size of the car and also make it look smaller. Now, talking about the flat underbody design. Now we know that the underbody of any car, for that matter, mainly consists of two things. One is the exhaust system, and second is some areas of the fuel tank. Now, when you
Correct.
talk about Honda Insight, the advantage is that the exhaust system and the areas of the fuel tank have separate fairings. Now, this helps in the flow airflow smooth airflow, which helps the car to function efficiently. Now, when you talk about smooth airflow, it is not just about the front design of the car or the body, but it also depends on the underbody system. Now, if you're talking about fairly smoothly traveling through the air, it can also lead to some amount of air leakage. And now, in order to minimize this air leakage, what designers do is they actually have observed this principle that the underside, the lower edges of the side, and the rear body, they form a strake. Strake is basically, it forms a strip which functions as an air dam. It creates a gradual increase in the body and it smoothly feeds into the underbody air, which means it gives in a little bit of air pressure into the rear of the vehicle, which will push the vehicle even more to travel smoothly into the air. Now let's move on to the next example. This image that you can see here are is the GM EV1 vehicle. Now, if you draw a comparison between GM EV1 and the Honda Insight,
you will see that both of them follow the same approach. You will see that GM EV1 almost matches fairly possible to the teardrop shape, and but the difference that you can see is that the rear wheels of EV1, as you can see here, it's 228 millimeter closer together, which means it's nearly twice as that of the inside Honda inside. Now you can actually think, why don't we use the same process or the same characteristics in a van, in a commuting van? But the problem is that a normal commuting van, which is traveling at a high speed and which is used for daily travel, it so happens that even if you suppose consider the considerations, like if you keep the wheels flat, and if you rapidly think about the curvature, and if you minimize the gaps, it might reduce the aerodynamic drag and help in the smooth functioning, but it will not be as efficient as GM EV1. So also another point is, when you're carrying out calculations to calculate the aerodynamic drag of two vehicles, it is suggested to compare the aerodynamic drag of two vehicles with the same shape and same size, or same shape and same design, rather than calculating between two uh, cars or vehicles having different shape or design. Now, for most accurate calculations, there is computational fluid dynamics. This is basically a digital way of calculating aerodynamics to be more accurate, and this will help us predict aerodynamic characteristics of vehicle precisely. Thank you so much.
So I really like the presentation because many of the part we knew, but we did not know this perfectly. So you two have really studied it well, whatever part was given to you, and you have explained this aerodynamic shape and aerodynamic design very properly. So those who will be presenting afterward, I would like you to follow the same rule that yesterday also it was told that don't try to explain too many things, don't give too many figures and all these things. Figures means I say numeric figures, but whatever small 3-4 slides you have prepared and you are explaining, do it from your knowledge point of view and whatever you have understood. So really, I congratulate Nitya and Rashmi. You have completed the job quite well, and your slide was also made quite well. But there were the same formatting errors. But anyway, your effort is really visible. Congratulations. Thank you. So next, I expect Matina and Nirav to come and upload the slide and
Yes,
present.